The Earth is ancient, billions of years old. A timescale so vast that it's difficult for us to conceptualize. Yet despite this, the geological scars imparted by the eons of time allow us to piece together the story of our world. We can't travel back into the past, but we can still reconstruct what happened. But what about the future? How will the world change? What will happen to this cradle of life spinning through the dark? How does the story end? Our ability to predict the future falls short when it comes to human society, be it a technological revolution, a stock market crash, or the collapse of a civilization. We have to accept that the future of our society is unknown and ultimately in our own hands. But the Earth is different, because over billions of years, the Earth is governed by physical principles like atmospheric chemistry, orbital mechanics, and radiative forcing. Things we do understand and things we can even make predictions for. So today, I invite you to join us for a voyage through time together. From the very beginning until the bitter end. A journey to the end of the world. To facilitate this journey, let's imagine that we somehow have the ability to travel through time, from Earth's genesis right up until its demise. You will essentially be a chrononaut, witnessing the eons play out firsthand. In total, we have about 12 billion years of history to cover. A useful device to contextualize this vast ocean of time is to compress each billion years into a month. So the history of Earth spans precisely one calendar year, born on January the 1st and dying on December 31st. At this scale, each day on the calendar then represents 33 million years, and each second is 384 years. Bracing for your voyage, you step into the time machine. It begins to warm up, and soon, blinding lights fill your vision. Nausea sweeps across you, and in the blink of an eye, we wake up at the beginning, Earth's first day. Stepping out, it looks like you're on an alien planet. This is the Proto-Earth 4.53 billion years ago. The surface is fractured, having only recently formed, and it's constantly changing as new meteorites come hailing down, smashing apart the young surface, adding to the Proto-Earth's growing mass. You look down at two watches on your wrists. Your left shows that just 3 minutes of compressed time have passed, but your right shows that tens of thousands of years have flitted by here on Earth. Looking back up, you see a dark sky smothered in ash and dust, with a faint, flickering sun barely perceptible through the clouds. The primordial atmosphere at this time is hydrogen and helium, the same materials from which the sun has also recently formed. You watch for hours as the proto-Earth accumulates more mass, yet actually shrinks in size. As the planet's mass and gravity increases, it compresses the rock beneath you. You look at your left watch to see that it's just gone 7 AM, whereas your right reads almost 10 million years. Up to now, the composition of the proto-Earth has been fairly homogeneous, rock mixed with metals. But around this time, something changes. The compression of the embryonic globe has caused it to heat up. Not only this, but much of the accreted material is radioactive, which in turn heats the planet up further. The surface and interior literally melt, forming a giant and deep ocean of magma. Within this fluid, heavy materials like iron and nickel sink under gravity to the very center of the proto-Earth, forming her core. As they move down, they rub against the mantle, generating friction and heat. The planet warms further, melting more rock and allowing yet more iron to sink. A runaway heating effect takes place inside the planet. You have just borne witness to the Iron Catastrophe, an event geologists long hypothesized about. Looking up at the sky, you see an aurora borealis for the first time, as this newly forged iron core has established a magnetic field around the planet, protecting it from the young sun's more harmful radiation. As the day comes to an end, this young world seems finally at peace after millions of years of tumultuous formation, internal hemorrhaging, and tortured resculpting. But a shadow looms, for Earth's suffering is not yet complete. It's about to face an event of unimaginable force and power, one that will reshape the planet forever. On the second day, you look up at the sky and see another small bright disk besides the sun bob into view sometimes, like it's coming closer and then receding away, a harbinger of doom. You realize then that it's Theia, a nearby Mars-sized world that's also recently formed. But unlike the real Mars, this body has become gravitationally trapped in Earth's Lagrange point, L4. But it's too big, too unstable to stay there, being tugged around by the gravity of not just the proto-Earth, but Venus and the other planets. It wobbles around precariously, menacingly, getting ever closer. It's at 7:02 AM that the sky turns dark and is consumed by Theia as it begins its final deadly plunge into the proto-Earth. Because of its smaller size, this is a suicide run for Theia, a battle it cannot win, yet it promises to cause as much devastation as it can in this sacrificial act. Worlds collide, vaporizing much of Theia and tearing off the Earth's newly formed terrestrial flesh into space. So violent, so powerful is this collision that it would be detectable from hundreds of light years away. Despite Theia's best effort, Earth somehow clings onto its existence, deformed, unrecognizable, but still standing. Much of what was the planet's material now orbits around it as debris. Some of it rains back down, punishing the Earth once again, but much of it coalesces via gravitation, forming rings, then clumps, then moonlets. As midnight approaches, you bear witness to the first moonrise. It's like nothing you've ever seen. The moon appears 30 times bigger than you're used to, being 30 times closer than the modern day. The Earth has become a parent as its daughter world now circles around its mother like a newborn fawn. Finally, the Earth can cool, can solidify, can move forward into her future. It's day 5. Over the last couple of days, comets have peppered the Earth. Each one has brought with it a supply of water, volatiles, and even organic molecules. There is now so much water that today you see oceans forming across the planet. The sight of a cooler Earth covered in bodies of water calms your mind. For the first time, you see something that resembles the planet that you know and love. It's Spartan and desolate, devoid of any life, but for the first time, it looks like the Earth. What excites you now is that life could surely start at any moment, and that you might bear witness to that first spark of emergence. January 14th. It's been 9 days since the oceans formed by your clock, but 300 million years have passed here in local time. The last week or so has been surreal. The Earth has a special beauty in this untouched, barren state. Wandering the surface, you find oceans, rivers, shorelines, each one a possible site for life's first moment. Organic chemistry is everywhere. Acetone, amides, nitriles, carbonyls, and even amino acids. Today, you explore a collection of hot springs up against the shoreline, land that will one day become part of Western Australia. It's here that you detect a small body of water with an elevated ratio of carbon-12 to its heavier carbon-13 isotropic counterpart. You remember that life prefers to take up carbon-12 over carbon-13 due to the lower energy cost of working with lighter molecules, and so this hints that life might be active here. You find the warm pool of pale water along the shore. It's loaded with organic molecules, alcohols and sugars. Excitedly looking at your scanner, you detect proteins, self-replicating chemicals, RNA and protocells. It's delicate, primitive, but unmistakably alive. You doubt that this pool is really the first instance of life, but it's so basic that what you're looking at is surely nascent. You pause in profound epiphany as you look down upon what is essentially the origins of you, your 4.1 billion year old ancestor. Clinging to its newfound existence, barely able to survive even in ideal conditions, these tiny cells will one day shape the world. As the days and weeks pass by for you, you watch millions of years flick by. Life has percolated now across the waters of the world. Despite being limited to simple microbial forms, macroscopic mats of these organisms, called stromatolites, betray life's expanding presence. The young sun is almost a third less luminous than the one that you know, but the Earth's atmosphere is rich in heat-trapping carbon dioxide, keeping it warm enough for life to thrive. As the ambient supply of sugars dwindles, with fewer cometary deliveries each day, life begins to adapt. On February the 1st, you find the first signs of photosynthesis within some cyanobacteria. These organisms pull in carbon dioxide and water molecules and use sunlight to forge their own sugars, producing oxygen as a waste product. At first, the oxygen levels are barely noticeable, but these photosynthetic life forms are so successful that they become ever more abundant. Beginning March 6th, you detect a rapid rise in oxygen levels, now creeping above 1%, 2%, 3%. But life on Earth is not adapted to an oxygen-rich atmosphere. This highly reactive molecule actually poisons much of Earth's life. You watch in despair as mass extinctions sweep across the planet, killing about half of everything that lives. In this era of change, the first eukaryote cells evolve. Sophisticated cells with membranes around their nuclei, larger volumes difficult for other cells to attack, and more efficient metabolism. Just 2 weeks later, on March 30th, you find the first colonies of these cells working together to form the first multicellular organism. Some of the cells in these organisms begin to specialize to specific functions, enabling yet more complex life to develop. It's on April 29th that simple animals first appear, like jellyfish and sponges. Up to now, life has largely been aquatic, leaving the land untouched. But on May 1st, Earth enters the Cambrian period, and with it, an explosion of life evolves in a diversity of new and wonderful directions, taking over the land and changing the oceans too. You've now been on your journey for 4 months, but 4 billion years have passed locally. It's staggering to think about the fact that so much time has passed here. Walking the Earth during this time is spectacular, a paleontologist's dream. Life is even more diverse than imagined. So many bizarre, failed evolutionary experiments. But through trial and error, life adapts, competes, and evolves into fascinating and complex forms. It's just over a week later, on May 10th, that the first dinosaurs evolved during the Triassic period. Watching these giants wander the Earth is a childhood fantasy. Creatures like the Allosaurus, the Stegosaurus, the Triceratops, and of course the Tyrannosaurus Rex. Each one simultaneously terrifying and captivating. You relish studying these giants, but just 5 days later, an enormous meteorite more than 10 miles across enters the atmosphere. The impact is truly decimating, raising a cloud of dust into the atmosphere that blots out the sun, darkening the skies, and cooling the world. You mournfully watch as the era of the dinosaurs abruptly ends, marking the transition between the Cretaceous and Paleogene periods. It is now, on May 15th, that small mammals start to fill the ecological niche left open. Your direct ancestors. You check your watch as history fulfills itself. In 2 days, on May 17th, you're past the date that you left the Earth. Thus far, you've witnessed the past play out, broadly familiar events inferred from the geological record. But now you're about to move into the future. You watch as the mammals advance over the Earth, growing in size and complexity. Great apes, hominids, Homo sapiens. This is it. You're about to see our own fate, the future of the human race. At 3:48 p.m., modern humans emerge. Just 13 minutes later, they begin farming and erecting buildings as you pass the Neolithic Revolution. Less than 1 minute after that point, 20,000 years by local time, it's over. Humanity is gone. The tape played so fast you couldn't see what happened to us. Did we move to another planet? Did we switch to artificial intelligence? Did we simply extinguish ourselves? In a flash, our cities and monuments crumble, decay, and disintegrate into dust, blowing off into the wind. Civilization doesn't rise again. For us, or for any other species. For the Earth will not sustain these ideal conditions which we enjoyed during our brief episode of thought, self-awareness, and reflection. The Earth's biosphere will only diminish from this point on. May 20th. It's been 3 days since humanity disappeared. For the umpteenth time, the continents have converged into a giant supercontinent. You sit there depressed, watching the eons flick by, the future unfold. The world is changing. When you first arrived, the Earth's atmosphere was rich in carbon dioxide, keeping the planet warm despite the sun's faint output. But over the past 4.5 billion years, the sun has grown more luminous as its core gradually contracts. It's now 30% more luminous, bathing the Earth in ever greater heat. As the insolation upon the Earth rises, evaporation cycles speed up, precipitation increases. As these rains fall through the atmosphere, the droplets soak up molecules of carbon dioxide, forming a weak carbonic acid. In human lifetimes, you'd never notice this, but now you see it. The rain dissolving away the rocks through weathering. The carbonic acid reacts with the silicate materials in the rock, forming carbonates that wash down to the ocean beds. The warmer the sun becomes, the faster this weathering occurs, pulling out ever greater amounts of carbon dioxide from the atmosphere, faster than volcanism or life's respiration can replenish it. The Earth is becoming starved of carbon dioxide. This is the way it's always been. Carbon dioxide and temperature in a constant back and forth, keeping the atmosphere at more or less the same temperature throughout the ages. A global thermostat operating on the timescale of hundreds of thousands of years. Because CO2 is a heat-trapping gas, its decreasing levels help keep the planet cool in the face of a warming sun. But carbon dioxide can only go so low. By May 27th, carbon dioxide levels have decreased so much that the bioproductivity of the planet is 1/2 of that of the era that you came from. Carbon dioxide is the fuel of photosynthesis, and without it, the food chain dwindles. It's ironic. The very chemical that humanity fought so hard to remove from the Earth's atmosphere is now the very chemical that the biosphere so desperately lacks. Over the next couple of days, you watch the sped-up Earth rapidly change. Forests become less common, animals fewer in number, and the planet becomes less green with each passing hour. It's on June 1st that CO2 drops to dangerous levels below 150 parts per million, leading to the mass extinction of all organisms that rely on the C3 photosynthesis reaction. But long ago, life evolved a more sophisticated alternative called C4 that can cope with CO2 levels as low as 10 parts per million. In the blink of an eye, these C4 plants and microbes fill the ecological hole opened by their demised cousins. But ultimately, this just delays the inevitable, as the sun just keeps warming, and so the CO2 just keeps tumbling. How long can this go on for? It's on June 13th that you get your answer. Your right-hand watch tells you that the year is 900 million AD. It's now that CO2 levels finally fall below 10 ppm, a critical value and the point where photosynthesis fails. Life cannot adapt. C4 plants like millet, maize, and sugarcane are the first to die, followed by photosynthetic microbes. The surface turns grey and brown. Within the space of 3 million years, or just over 2 hours by your watch, you are now forced to bear witness to the most heartbreaking spectacle. Without photosynthesis, oxygen levels rapidly decline across the world. Large herbivores are the first to perish, their food supply gone. Large placental mammals go next with their relatively high oxygen requirements. Next, you watch as small mammals die in their burrows. Birds fall to the ground. Dead fish fill the oceans. By the end of this terrible 2 hours, even invertebrates like the insects are gone. The Earth's oxygen has been depleted. The reign of multicellular life is over. You reflect back that it was a good run. For 2.5 billion years, they roamed the Earth, about 20% of the planet's lifetime. But now you look out at an Earth that has gone into shock, returning to its earlier microbial era. It's still a living world, but one very different from the one that you once knew. With the carbon dioxide depleted, there's no buffering left for the Earth's temperature. The planet begins to rapidly warm. Not only does the temperature rise, but surface water becomes more saline, salty, as water evaporates away. The remaining life departs the equatorial zones and finds some solace in the polar regions and high-altitude lakes, where the temperatures remain cool. Life might be restricted to microbial forms as it was in the earliest days on Earth, but this life is far more sophisticated. For unlike those primitive, simple life forms, the microbes living now are the product of 5 billion years of evolution, highly competitive Darwinian natural selection honing their genomes. In particular, extremophiles adapted for high temperature and saline environments resist extinction and persist as the Earth warms. Watching this play out gives you some comfort to see these advanced cells stare down the Earth's warming climate. At least they still hold the torch of life going. Towards the end of June, over 1 billion years into our future, the Earth's daughter, the Moon, has gradually receded away so far that its gravitation no longer acts to stabilize the Earth's obliquity. This causes the planet to axially precess, leading to much greater seasonal variations. Much of the Earth becomes uninhabitable, even to extremophiles. By July, what little life is left is forced to hide away from the surface, either deep underground or take refuge in cold-trapped caves formed by collapsed lava tubes. On July 25th, the Earth's core, which has been gradually cooling since its inception, finally solidifies, leading to a total collapse of the Earth's magnetic field. By now, the global mean temperature is over 100 degrees Celsius, and the oceans rapidly evaporate. The water content of the atmosphere and even the stratosphere rises, tipping the Earth into a moist greenhouse state. This high-altitude water is split by the sun's ultraviolet radiation into its constituent hydrogen and oxygen atoms. As the oxygen sinks back down, the lighter hydrogen escapes into space. Through this process of photodissociation, the Earth begins to rapidly lose its water content, much like what happened to its sister planet Venus eons ago. By the end of July, 2.5 billion AD, the oceans are gone, and the Earth is a dry, barren world. This is the end for life. Without water, nothing can survive. The future from here is sterile. Plate tectonics shut down and the mountains weather away. The world looks alien, more like Venus than your Earth. The sun continues to grow ever more luminous over the billions of years that pass, scorching the Earth's inanimate surface. As the sun's core converts hydrogen to helium, it contracts, raising the internal temperature and pressure, which has largely driven the changes you've observed throughout the sun's history thus far. But by October 30th, 5.5 billion years into our future, the core is now so hot that the surrounding hydrogen begins to fuse, causing the sun to now finally leave the so-called main sequence phase of its lifetime. As this shell of hydrogen burns around the core, it deposits energy directly into the surrounding envelope, causing the sun to expand. At first, this expansion is gradual, but it heralds the demise of the Earth. It's December 31st, the Earth's last day. You know that the sun is bracing to enter its giant phase, an episode of rapid and deadly expansion. As that final evening breaks, you watch the sun grow in size in your red sky. It morphs in color, reaching beautiful deep orange hues, growing ever larger. By 9:15 p.m., the planet Mercury has been swallowed by the sun. Yet the sun's appetite is not yet satisfied as it continues to swell. At 11:16 p.m., you watch in awe as Venus is engulfed. The sun is terrifyingly, unimaginably large, a red giant filling nearly 1/2 of your sky. With each and every minute, it expands further. But perhaps there is some hope, for as the sun has evolved, it's lost about 1/4 of its mass, causing the Earth's orbit to move slightly outwards. Like a game of cat and mouse, you wonder if this movement is far enough to escape engulfment. Maybe the Earth will be spared being swallowed whole. But as the sun closes into its prize, in that final terrible hour, the Earth literally drags through the stellar chromosphere and now starts to spiral in towards the sun, not away. As the Earth reverses course, you accept that it's over. Here, at the end of all things, your sky is filled with fire as the Earth finally rests, returning to its maker. In Earth's 12 billion year old story, life blossomed for just over half of its age, and multicellular life makes up just 1/5 of that story. And humanity? Well, we may be just the blink of an eye. We recognize that where we live is special, but so too is when. For we live in Earth's glory days, a world of temperate conditions, stabilized obliquity, active geology, and diverse, flourishing life. An era where not just multicellular life is possible, but animals, agriculture, and even civilizations. Ultimately, the fate of ourselves is up to us. We can choose to accelerate our demise, or we can look after our world, its life, and each other. The candle doesn't have to go out here. New stars, new worlds are forming right now. The universe offers infinite potential to those who dare. And so where we go from here is a choice that I leave to you.
The truth is so remarkable, so amazing. That's a much more exciting story to many people than the tales which other people used to make up, who worried about the universe, that we were living on the back of a turtle or something like that. They were wonderful stories, but the truth is so much more remarkable.